Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Citra Septiana. You can call me Citra. I'm from Mathematics Education of Hamka University. In this video, I will explain about annuity. Annuity is divided into three. The first is ordinary annuity, the second is due annuity, and the third is deferred annuity. Okay, I will start explain about ordinary annuity. Time diagram of Componentaries. Payment of the first years until payment of end years. We can get A value equals P times 1 plus R to the power N. P equals A divided by 1 plus R to the power N, or A times 1 divided by 1 plus R to the power N. And the not 1 divided by 1 plus R is I. We can substitution 1 divided by 1 plus R with I. So we get present value equals A times I plus A times I squared until A times I to the power N. From here, we can get geometry sequence. So present value equals A times I times 1 minus I to the power N divided by 1 minus I. We can change our substitution I with 1 divided by 1 plus I. So we get this equation, and we get the first equation, present value equals A times 1 minus 1 plus R to the power negative N divided by R. Okay, example for the present value. What is the present value of 100,000 that will be received every 3 months for 1 year with an interest rate of 2% every month? As now, A equals 100,000, R is 2% multiplied 3 equals 6% equals 0.06, and N equals 4. As now, substitution for the formula present value, and we can get present value is equal 310.56. Okay, periodic payment based on the formula for the present value of an ordinary annuity in equation 1. In equation 1, present value is equal A times 1 minus 1 plus R to the power negative N divided by R. We can get formula of A is equals present value times R divided by 1 plus R to the power N. Okay, time period based on the formula for the present value of an ordinary annuity in equation 1. Present value equals A times 1 minus 1 plus R to the power N divided by R. We can get the formula of N equals log A minus log A minus present value times R divided by log 1 plus R. Interest rate. Step 1. Find a value of two present value that are greater and less than the desired present value by plugging any value of R into the present value formula of the annuity. Step 2. After obtaining an interest rate that produces a higher and smaller present value, use the following interpolation. R minus R2 divided by R1 minus R2 equals present value minus present value 2 divided by present value 1 minus present value 2. Years. Okay, future value, the first payment at the end of each year for 10 years. In the time diagram of Componentaries, we can get equation 2 for future value is equals P times 1 plus R to the power n minus 1 divided by R. Example, assume someone decides to invest 125,000 per year for the next 5 years in an annuity they expect to compound at 8% per year. The expected future value of these payments using the above formula is as follows. As now, P equals 125,000, R is 8%, and N is equal 5. We can substitution as now for or in future value formula, and we can get 320 periodic payment. Based on the formula for the future value of an ordinary annuity in equation 2, we can get P equals future value times R divided by 1 plus R to the power n minus 1. Time period. Based on the formula for the future value of an ordinary annuity in equation 2, we can get formula of n equals log P plus future value times R minus log P divided by log 1 plus R. Interest rate step, find two values of future value that are greater and less than the desired future value by entering any value of I into the formula for the present value of the annuity. After obtaining an interest rate that results in a greater and smaller future value, use the following interpolation. R minus R2 divided by R1 minus R2 equals future value minus future value 2 divided by future value 1 minus future value 2. And now I will explain about due annuity. Annuity due is an annuity whose payment is due immediately at the beginning of each period. Due annuity is divided into two, present value and future value. And period of due annuity, time of diagram of compound interest. We can get A equals P times 1 plus R to the power n, and we can get the formula of present value of due annuity is equal A times 1 minus 1 plus R to the power minus n divided by r times 1 plus r. This is equation, the first equation of duality. Example, Kai wants to apply for a loan payable over a period of a year from a bank that charges 12% interest per annum, compound annually. If he can only be able to pay back $10,000 per annum at the beginning of each year, which is the loan amount he will get. Now, A, R, and N are present value. We can substitution as amount for the formula present value, and we can get $40,373.49. Periodic payment based on the formula for the present value of an annuity in equation 1. We can get formula for A equals present value times R divided by 1 plus R minus 1 plus R to the power negative N plus 1. Time period based on the formula for the present value of annuity in question 1. We can get formula for N equals minus log 1 minus present value times R divided by A times 1 plus R divided by log 1 plus R. Interest rate. Step, find the values of present value that are greater and less than the value of present value by entering any value of I into the formula for the present value of the annuity. If the present value obtained is greater, increase the interest rate in order to get a lower present value and vice versa. 2. After obtaining an interest rate that results in a greater and lesser present value, use the following interpolation. R minus R2 divided by R1 minus R2 equals present value minus present value 2 divided by present value 1 minus present value 2. And future value and period of duality. Time diagram of compound interest. We can get formula of future value is equal P times 1 plus R to the power N minus 1 divided by R times 1 plus R. Okay, example, $1,000 is interest at the beginning every 3 months at 4.8%. Compound quarterly. How much will the annuity be worth in 10 years? Noun P, R, N. How much future value? Based on the formula of the future value annuity due in equation 2, we can get future value is $51,566. Periodic payment based on the formula for the present value of an annuity due in equation 2, we can get formula of P equals future value times R divided by 1 plus R to the power N plus 1 minus 1 plus R. Time period based on the formula for the present value of an annuity due in equation 2, we can get formula for N equals log future value times R divided by P times 1 plus R plus 1 divided by log 1 plus R. R minus R2 divided by R1 minus R2 equals future value minus future value 2 divided by future value 1 minus future value wabarakatuh. So, the explanation from me. I hope this video can help you. Thanks for watching this video. Wassalamualaikum warahmatullahi wabarakatuh.